Hi everyone, so this is question 10 tutorial 23, which says find the indicated roots expressing the results in the form x plus iy unless tables would be needed to do so. So for this question, what you need to put in mind is that you're going to be using de Morville's rule. So de Morville's rule is what we're going to be using on this question. And then apart from that, you need to put in mind to say whenever you're finding the roots of complex numbers, you first have to convert them into polar form. So I think now we can start with question 1. So I'm not going to answer all the questions because I'm pretty sure you know that these questions are complex. So if it means me answering all these questions, it would take hours for me to finish them. And looking at the things that I'm using, if I was using a pen, I would have answered all of them. Now the laptop that I'm using, it is somehow very slow when it comes to writing such things. So I'm only going to answer probably 3 questions that I know that they are a little bit complicated. And looking at these questions, I think it's question 1, 2, and question 4. This one is an example in your module for mathematics, so you can go and check it up. And then this one, I think it's also an example. I've seen something like this in your module. And then if this one is not an example in your module, then try to you can do it on your own, because the only difference that is going to be between this one and this one is only the quadrant where they are lying. So if I can answer the first one, it means that I can also answer the last one. It also means that I can also do the 60th one here. So I'm going to start with this one. So I'm going to start with this one, which is that, so the square root of this is just the same as writing it in this way. Z is equal to the square root of that. And then this can also be written as 1 plus I root 3 in brackets. So the square root of any number is just the same as raised to the power half. So that is the square root of the number. And again, so in this case, we can now find. I'm pretty sure some of you have already gone in your module. You've gone through your modules, and so far you know to say. First of all, you need to find the value of k. Or let me just write, for the sake of revision, I'll write the formula here. So if you are finding the nth root of a complex number z, so the nth root of a complex number z is given by r raised to the power or simply just the nth root of r, and then open brackets, then you say cos theta, then plus 2. So if you don't want to use 2 pi, you can use 360 2 pi k, or you just write 360k. You can put 360k here or 2 pi k, depending with the angle that you have chosen to use, whether it's in radians or in degrees. So you close them in brackets like that, and then plus sine. Again, you repeat the same thing, theta plus 2 pi k. So theta plus 2 pi k over n. So this is how you find the roots of complex numbers. So one may be wondering, what is this k, and then what is this n? So this is what I'm going to be explaining here. Just pay attentive. So the value of k is just simply number starting from 0. You write 1, 2, then it goes on like that up to the point where it is n minus 1. And then the value of n is simply just n, which is the one that is just in front. It is just the nth root, in short. So according to this question, let us find k. So k is equal to, I'll start from 0. So my n, or maybe before I find k, let us start first by finding n. So my n is just nothing but these two here. So that is my n. So meaning my values of k are going to be, so my values of k are going to be 0, and then I know to say, when I say n minus 1 is just the same as saying 2 minus 1. I'll put 2 there and then minus 1. So 2 minus 1, I'm getting 1. So the last number of k that I'm going to have is 1. So these are the two values of k that I have. And then you move on now to finding the roots. So we're going to have z0 and z1. We just use these numbers here. So z0 is going to be, where there is k in this expression, I'm going to be putting 0, and then where there is n, I'm going to be putting 2 in this case, where there is n. Then before I start finding z0 and everything, I should first convert this complex number into polar form, as I earlier on said. So I'll convert it. So my conversion is going to be like this. So my r, first I have to find r. So r is nothing but the square root of 1 squared. So 1 squared is going to be 1, and then plus, and then we all know how to find the magnitude of a complex number. So, and then the root of 3 squared, I'm going to get 3. So 1 plus 3, I'll get 4. So in short, it's going to be the square root of 4, which is nothing but 2. So the square root of 4 is going to be 2. So now this is going to be 2. So meaning my magnitude is going to be 2 there. Then I'll open the brackets. Alright, cos. I also now need to find the argument. So the argument, let me just do this. So the argument is given by tan inverse. So the argument is tan. So tan inverse. So this is my theta. So my theta is going to be tan inverse of y over x, which is root 3 over 1. Root 3 over 1. So this is going to be tan inverse. So theta is going to be tan inverse of root 3. So tan inverse of root 3 will give you nothing but 60 degrees. So you also have to check where this complex number lies. You draw a simple Argand diagram. So when plotting these numbers, you discover that 1 can be there, and then the root of 3 can also be there. So meaning it's in the first quadrant. So if it's in the first quadrant, then we get this same angle as our theta. So theta, so z is going to be 2 cos 60, and then plus, sorry, I forgot to put I here, and then plus I sine 60 degrees. So after doing this, so this simply means that if I raise this z to the power half, which is just the same as the square root of z, it means that I should also raise if I raise this to the power half, means that I should also raise this complex number to the power the same half. And then from here we can start finding our roots now. So we first find z0. So z0 is nothing but, you remember what we are doing in the first part of the models. When let's take for instance you have this to the power, this complex number is raised to the power of 2. It means that 2 is going to be distributed to these 2. Now in this case we're going to distribute this half to these 2. So meaning we're going to say 2 to the power half, and then I'll open the brackets. Let me open curly brackets, and then I'll say cos. So I'm going to write cos 60. Remember what we said? We said theta plus 2 pi k, or theta plus 360 k. So we're going to say, since we are using we're not using radians, or we're using degrees, we're going to use 360. So it's going to be 60 plus 360, 60 plus 360, and then our value of k here will put 0. So when you multiply 360 times 0 there, let me first draw this, and then over our n there, we said n is equal to 2. Our n is just this, that is the denominator of the fraction above. So this is how it's going to be. So but remember, when we multiply this 0 times 360, 0 times 360, you get 0. So which is just the same as writing 60 plus 0 over 2. And then 60 plus 0 is just 60. 60 divided by 2. So that is how it's going to be. So let me just write it directly. Yeah, so 60 plus 0 is equal to 60 divided by 2. So 60 divided by 2, you get 30. So let me also write this. Instead of writing 60 over 2, I'll just write 30 there. 30 degrees. Alright. And then I proceed like that. So this is going to be I. And then I'm going to have sine. I'm going to have sine 30 also here. So this is going to be my z0. So this is going to be my first z, which is z0. Then I move on to z1. I'm getting the value of k now, which is equal to 1. So z1 will be nothing but, this one can also be simplified. Any number to the power 2 is just the same as the root of 2 any number raised to the power half, sorry, not to the power 2, but any number raised to the power half is just the same as the root of 2. And then you open the brackets like that, then you say cos 30 plus I sine 30. So that is going to be a Z1, the Z0. So we start now finding Z1. So Z1, same applies. We know that 2 raised to the power half is the root of 2. So I'm just going to write the root of 2. The magnitude doesn't change. So the root of 2 here, the magnitude doesn't change. And then I'll open brackets. Open these big ones. Then I'll write cos. My theta is 60. So I'm going to write cos 60. I'm going to write cos 60. So cos 60 plus 360. I'm following the formula here, 360 times k. So my k now is going to be 1. So 1 times 360 is just the same as 360. Then divide by, my value of n there is 2. So I'll put 2 there. Then plus I sine 60 plus 360 everything over 2. Then I'll close my brackets like that. Then I'll do it. So now it's just a matter of simplifying this. So Z1 is equal to the root of 2, then 60 plus 360, you get 420, divide by 2, you get 210. Then you have cos 210 degrees plus I sine, so plus I sine 210. So that is going to be a Z1. So this is going to be a Z1. And the question is done. So if you've been told to plot this on the, before I say the questions are done, the question is saying we leave it in the form x plus I y. So how do you do this? I'll start with the Z0 there. So Z0 is there. How do you convert that now in the form x plus I1? We want to leave it in the form x plus I1. So how do you convert it there now? So this is just going to be equals to, I'll write this root 2 outside like that. And then open brackets. So cos 30, I know to say it's root 3 over 2, and then this is going to be plus, then sine 30 is just nothing but half. It's going to be half I. Then what you do there is you multiply with throughout with this half. So this root 2 times root 3 there, you discover that your answer will be root 6 over 2, and then plus you multiply your root 2 times half there, your answer will be root 2 over 2I. So this will be your final answer. Then we move on to the second root here, which is z1. We also convert it, so this is equal to, so finding cos 210. Finding cos 210. Remember the compound angles. So cos 210 on compound angles, you find two angles that you are going to add or subtract, and then you have to replace them in one of these two equations here. So how can you have 210? So 210 can be gotten by either adding, let's just do the addition. So 210 can either gotten by either adding 180 and 30. When you add 180 plus 30, you get 210. So on A here you put 180, and then plus on B you put 30. So in short, you find two special angles that you are going to add to give you 210. Same applies to finding sine 210. So sine 210 is also gotten in the same way. Sine 210, you also have to add 180 plus 30. 180 is a special angle and 30 is a special angle. So when you add 180 plus 30, you get 210. So when you get your 180 and your 30, you come and replace them there. Where there is A, you put 180, where there is B, you put 30, and then you use this formula to find your solution. So this is how you find it, and you get your answers to be, so you get your answers to be the root of 2, then open brackets. So when you use this compound angle formula to find the cos 210, you discover that your answer is going to be the root of 3 over 2, and of course it's going to be negative. And then when you use the same compound angles to find the sine of 210, you find your answer to be I1 over 2. It will also be a negative like that. So once you find that, you can multiply through by the root of the root of 2. The root of 2 times that, you find the root of 6 over 2. It's going to be a negative. Then minus the root of 2 over 2. So this is going to be your answer, this side. So this is going to be your Z1. So this was our Z0, then this is our Z1. We move on to the next question. So our next question is the cube root of 27i. The cube root of 27i. So the second question is the cube root. So our z is equal to, they're saying the cube root of z, meaning the cube root, our z was 27i. So how do you do this? The way you do this, as I earlier on said, you first have to convert this complex number into polar form. So this one can also be written in other ways as the cube root. Here there's supposed to be 3. The cube root of, so this can also be written as 0 plus 27i. So they want us to find this. In other ways, again, we can write it as open brackets 0 plus 27i. So the cube root is nothing but the same as 1 over 3. Alright, so this is good. Yeah, so we first have to find the magnitude of that. So we find r, the magnitude of that complex number r is going to be the root of x squared, so meaning 0 squared, then plus 27 squared, which will just give you the same 27 as your answer. So 27 squared is going to give you 27 as your answer. So this is the magnitude of that complex number. Then apart from that, now we also have to find the argument. The argument, so finding the argument is just the argument is theta. So the argument is theta, which is equal to tan inverse of y over x. So tan inverse of y, what is my y? My y is 27, and then my x is 0. So tan inverse of this is just the same as tan inverse of 0, or tan inverse, sorry, not tan inverse of 0, but tan inverse of infinity. Any number divided by 0 is undefined. So tan inverse of infinity, you get your answer to be 90. Your answer is going to be 90 degrees. Then let us also see in the quadrant in which this complex number lies. So the quadrant, our 0 of course will be there in the real axis, and then in the imaginary axis we need to move 27 units according to the question. So I'm moving 27 units in the imaginary axis, which is just going to be like this. Alright. So this is our complex number z. This is going to be our complex number z. And then apart from that, we can also do something here. Yeah, since we have found the argument and the magnitude, I think we can now start finding the values of k. So remember what I said, the values of k are numbers ranging from 0 up to n minus 1. So the value of n, so my n is equal to, is this one here, or you just get that 3. So my n is 3. So my k will range from 0. So my k is going to be ranging from 0 to n minus 1. So n minus 1 is just the same as 3 minus 1, which is equal to 2. So let me find my first complex number. So my first complex number, my first root is going to be z0. So my z0 will just be the magnitude that I've found is 27. 27 to the power the cube root of 27. So the cube root of 27 will give me 3, or I'll write that on the next stage. And then I'll open brackets cos. The cos of my theta here, the argument there is 90, cos 90 plus 360 times, of course my value of a is 0, so my value of a is 0. So when I put 360 times 0 there, it's just the same as 0. So I won't just write it. And then so 90 plus 0, everything divided by 3, you have your answer to be 30, and that is going to be your final answer. Then after simplifying it, you have that. then z1 is equal to 3 cos 90 plus 360 times your k, which is 1 over 3. And then when simplified, that answer is going to be 150. Let me just write it here. Okay, it's going to be 150 degrees. 150 degrees plus high sine 150 degrees, sine 150 degrees, then close the brackets. You can also simplify this. So cos 150 degrees, you can also use the compound angles to find this. Cos 150 degrees. So how else can you find 150? 150 can either be found by adding 120 plus 30. Oh, sorry, 120 is not necessarily a special angle, but you can also find the. Okay, so 150 can be found by adding or not adding. You can find 150 by subtracting by adding 90 and 60. So when you add 90 and 60, you get 150. So you put your 90 there and your 60 there and find everything. Same applies to finding sine 150. Sine 150 can be found by adding 60 and 90 and replace them there in this equation. You find your answers to be so sine. So this is going to be give you sine cos 150 will give you negative root 3 over 2, and then plus sine 150 you get 1 over 2 I. So this is going to give you 3 times that, you get negative 3 over 2 root 3, and then plus 3 over 2 I. So this is your Z1. We quickly move on to finding Z2, the last Z that we're finding on this question. So Z2, you just replace where there is K with so my magnitude there will always be 3, and then open brackets. So it's going to be 3 cos. It's going to be cos theta. My theta is 90. So my theta is 90 plus 360. So my value of K there is 2 now. I'm putting 2 there. Then everything divided by n, which is 3. So my value of n is the power, since we're finding the third root. So when you calculate this, you find that your answer is going to be it's going to be 270. So you write it like that, plus I sine 270. 270, close the bracket, which is equal to, so cos 270, you use compound angles again. You find 2 special angles that you can add or subtract in order to give you 270, and then you replace them in one of these formulas here on cos, and even the same applies to sine. Then so this is going to be 3 open brackets, and then cos 270 you get 0, and then sine 270 you get negative 1, which you just write as negative I. So here your complex number will be 0, negative 3 I when you open the brackets like that. So this is going to be your Z2. let's quickly move on to the next question. So the next question I said I'm going to answer here is the fourth question here, because this one, the second question, or rather the third question, is in your module, and if you can manage to answer the first question, then you can also answer the sixth question and the seventh question here. They are all straightforward. So let me do the fourth question there. Which is just saying find the fourth root of 8. So my z is equal to 8. So when they tell me to find the fourth root of 8, the fourth root of z is just the same as the fourth root of 8, which is equivalent to 8 power 1 over 4, which is also equal to 8 plus 0I, then to the power 1 over 4. So first things first, you start by finding r. So r is nothing but the square root of 8 squared plus 0 squared, which will just give you the same 8 as your magnitude. And then you find the argument. Now the argument, which is theta, is going to give you tan inverse of, so tan inverse of y, which is 0 over 8. So y over x, which is 0 over 8. So 0 over 8 is just the same as tan inverse of 0, like that, which will give you 0 as your answer. So 0 degrees is our argument, and then from there we can now try to draw the. From there we can now try to sketch the Argand diagram. We see where our complex number lies. So this is the magnitude. I mean, this is 8. And then in the y, so it's moving 8 units in the x, and then in the y it's moving 0 units. So it's the complex number is going to move like this. It's moving 0 units in the imaginary, and then it's moving y in the what? In the x component. Actually it was supposed to be in this line. Yeah. So this is going to be our complex number. It's going to be like that, up to 0.8 there. So we now begin to find the sign. So n, the value of n there is equal to 4. So and then the values of k that we are going to have are 0, 1, 0, 1, 2, up to 3, like that. So 0, 1, 2, 3 are the values of n that we are going to have. And then we move on. So the first z0 that we're going to have will just be equal to, our magnitude there is 8. So our magnitude 8 to the power 1 over 4, which is the fourth root of 8. The fourth root of 8, and then we say cos 0 plus, because when you add 0 plus 0, our theta is 0. So when you add 0 plus 360 times 0, it's going to give you 0. Divide by 4, you still get 0. And then I sine 0. Then when you reduce this, you are going to have the fourth root of 8. Then open brackets. Cos 0, you get your 1 there. And then sine 0, you get your 0 there, 0I. So your complex number, your z0 is going to be, your z0 is going to be the root of 8, the fourth root of 8. fourth root of 8 plus 0I. This is going to be your first complex number, which is your Z0. Move on to Z1. So Z1 is going to be the fourth root of 8, open brackets. This is going to be cos. So the cos of 0. So it's going to be 0 plus 360, which is 360. Then 360 divided by 4, you get 90. So it's going to be cos 90. Then plus I sin 90. Then close brackets like that. So you find cos 90 is going to give you 0, and then sin 90 you get 1. So cos 90 you get 0, so you write the fourth root of 8 there, and then cos 90 you are getting 1, or cos 90 you are getting 0, then sin 90 you are getting 1. 0 plus I. Then so your Z1 there will give you nothing but 0 plus the fourth root of 8. 0 plus the fourth root of 8I. So this is going to be your Z1. Then apart from that, we move on to finding Z2 and Z3. So Z2, you just replace where there is k with 2. So the first thing here, you write the magnitude, which is the fourth root of 8. Alright, the fourth root of 8, then open brackets, then cos. So 360 times 2 plus 0 is just the same as 720, and then divide by 4, you get 180. So this is the same as cos 180, then plus I sin 180 degrees. So you convert this, you are going to have something like this, 4, and then the fourth root of 8, and then you find cos 180, your answer will be -1, and then sin 180. So cos 180, your answer will be -1. So you have -1 here on your real part, and then plus sin 180, you get 0. So you're going to have 0I this side. So your Z2, so Z2 is going to be the fourth root of 8 times that, so it will be negative fourth root of 8, and then plus 0I. So this is going to be your Z2. Move on to Z3, the last part. So Z3 is also equal to, you find the fourth root of 8 there, you write it, and then open brackets. This is going to give you cos. So our theta is 0. 0 plus 360 times 3. So 360 times 3, you get your answer to be 1080. Then 1080 divided by your fourth root, which is 4, it's going to give you 360. So this is going to give you 360 degrees. So 360 degrees, and then plus I sine 360. So sine 360 then you just simplify it. So it's going to give you, so Z3 is going to be the fourth root of 8, and then open brackets, then cos 360 you get 1, and then sine 360 you get 0. So cos 360 you get 1, then plus 0 I. So Z3 is now just going to be the fourth root of 8 and plus 0 I. So this is going to be your Z3. So thank you for watching the videos. Make sure that you subscribe to the channel. If you have any questions or any contributions, you can send to this line here on WhatsApp. I'll be there to answer you. So I've done this very quickly because my battery was almost shutting down due to this issue of load shedding. My laptop is almost shutting down. Yeah, and then as I earlier on said, this one we've answered these at least, which are a little bit complicated. The remaining ones are straightforward. You can do them. This one I saw it in your module, so I don't think it's going to be a problem with you guys. Okay, so just make sure that you subscribe to the channel for more videos so that you don't miss out. Alright, it's giving 1.8.